Hello everyone. In the last session, we have discussed about two-tier architecture. It is commonly called as a client-server architecture. In that session, we have discussed how the request is given from the client to the server, and once the request is given from the client to the server is processing the request, and response is given again back to the client. Okay, so generally, in a client server architecture, we are having only two tiers. One is called as a client tier, and the second is called as a server tier. We will not call these things as a client machine or server machine. So we have discussed these things. Okay, we called it as a server tier or client tier because in case of client tier, we are having a number of customers across the globes, and it is of a different kinds. Right? What it means by different kinds? That our customer, okay, who requires services from a server, right, or who demands the services from the server, okay, that particular customer, that particular client may be using some laptop, it may be using some desktop machines or smartphones, smart devices, tablets, and so on, right? So any smart device, any computing device that particular client or customer is using, and using that such smart device which is having a internet connectivity, is that particular client is giving a request to the server, right? And once the request is given to the server is having a set of machines, okay, and they are interconnected with each other. So if you have designed a server, okay, at Bangalore location, it may consist of 100 machines, it may consist of 1000 machines, 500 machines. It depends upon the application to application, as well as complexity of application, and it also depends upon the organization in which you are working. So we cannot say it is a server machine. Okay, ideally we should call it the server tier. On a single server tier, on a particular server tier, we are having a set of machines, set of server machines which are interconnected with each other. Similarly, you are getting a request from across the globes from a different clients or customers, and they are using a different devices, right? So you have created some application for which you are providing services from 1 lakh people or 10 lakh people, and then in that case the 10 lakh clients or customers may be using a vast range of devices, smart screen devices, right, or computing devices. So better it is to call it as a client tier, and similarly here we call it as a server tier. Now the next thing is that generally, on the particular client tier in this particular two tier architecture, it is also called as a presentation tier. Why is it called as a presentation tier? Because you are giving just a GUI interface, that is a graphical user interface, to your customers. You are not disclosing as an application. If you are an application programmer, then in that case, as an application programmer or as a software organization, we are not giving any code to our customer or client. We are just giving the user interface, and by using that user interface, customer or our client is communicating or connecting with our server and getting the services, right? So if you take any example, okay, for sake of understanding, I am taking an example of net banking. Okay, better in PSU, we are having a leading organization, leading PSU bank, that is the State Bank of India, and that State Bank of India is having an online SBI interface. On that online SBI interface, for the customers, that is for account holders, they are providing the GUI interface. Okay, on using that GUI interface, customer or the account holder can enter its use credentials, that is a username, password, along with the captcha, and that particular customer can log into the system. Okay, once that customer is logged into the system, customer can perform a set of tasks, set of activities, that is creating FD, RD, then creating opening a PPF account, and so on, right? Okay, or applying for a loan, okay, applying for a NPS account, PPF account, as well as NPS account, okay, and so on. Also that customer can see it is his or her own bank statement, account statement, okay, for the given period, for a particular range of days, and so on. So there are number of functionalities can be handled by the customer, or a customer wants to handle, and these functionalities are provided by this particular backend software, right? So but at the backend we are having some application logic, or we are having some database. If you are the software organization providing services for the state SBI, in that case, okay, you are maintaining some application logic as well as you are maintaining a database, right? So you should have a information of every customer, okay, for that particular organization, for that particular bank, okay, in your database it is required. And once that particular customer is demanding for the services, then you have to reproduce that data, as well as you can you have to modify the data, okay, and so on. So there are a number of functionality customer wants to perform, and these functionalities are performed at the presentation tier and at the backend. Okay, as a programmer, okay, we are maintaining the application logic as well as we are maintaining the database part. Okay, so client tier is also called as the presentation tier, and server tier, it consists of different functionalities. At the server tier we are maintaining a application logic, okay, in this case we are also maintaining the database logic, okay. So in case of two tier architecture, what happens, okay, at the server tier we are performing as a programmer, or as a software or as a software organization, we are performing both the tasks, that is maintaining the application logic or application code as well as maintaining the database. But okay, so due to which what happens, okay, so these applications are easy to implement, right? So because we are having only two tiers, client tier and server tier, and this application logic and database part are combined at a server tier only. So these applications are easy to implement, but they are difficult to maintain. Why is it so? Why is it difficult to maintain? Okay, application creation, okay, is a one part, one task, and application maintenance is another task. Now I will give one small example to you. Okay, let us suppose you are a civil engineer working for some organization, for a civil organization, and you are handling the road contracts. Okay, so you are as a civil engineer, okay, you have to create a DPR, that is the detailed project report for to construct that road. Then you have to purchase the material, then you have to perform the task with the help of your workers and so on. So if you are doing all these activities, then it is very difficult for you. Okay, these activities are easy to implement as far as your civil organization, as far as your company, because company is giving some timeline for you. Okay, within 6 months and for this particular budget you have to perform this task, you have to construct a road. But as a civil engineer it is very difficult for you, because okay, in order to create a DPR you require a civil engineer skills as well as management skills. You should have some profit and loss account. Okay, you should know about about the cash inflow, cash outflow. Okay, so you should know about the some commercial activities also. You should have some management skills also. Okay, once you created the DPR, the one, and that particular DPR is sanctioned, then you have to purchase the materials. For that also you should have some management skills. Then you are using n number of workers to perform that particular activity to construct a road. Okay, for that also you require some management skills. And at the end you have to check the quality for the road, right? So you want to construct a road, okay, at the best quality, right? So in that case, in the last part of your work or job, okay, you are having some civil engineer skills, but before that you require some management skills. Okay, so as an organization it is easy to implement, because as an organization they want to hire just a civil engineer. Okay, but it is very difficult to but it is difficult for civil engineer side. It is difficult to maintain also. Once that particular road is created, then there is a maintenance activity comes, right? Okay, that road should maintain for a 5 years, 10 years, and so on, right? So for that you require some maintenance activity. If you see the roads constructed in our area also, okay, they have constructed well, okay, at initial stages, but they haven't maintained well. That's why, okay, that their condition is very, very poor. Okay, in some cases it is there, in some cases they are maintained well also. Okay, in that case such roads conditions are very good, okay, or better as compared to the other roads. You can observe this particular fact. Okay, similarly in case of software also it is there. Okay, you have implemented a software easily, but that management, that is a maintenance of the software is also very important. Okay, so if you are using a two-tier architecture, that is a client server architecture, then in that case it is very difficult to maintain, because application logic is combined with the database part. So client is communicating with the server tier, okay, with the help of presentation tier. And if okay, in a particular case, particular malicious activity is performed by some person, some client, okay, and or a particular client is attacking on your machine, or on your server tier, in that case that particular customer or client or attacker is having access to your application logic. At the same time, that attacker is having access to a database part also, and that is very crucial. Okay, I have already told you, in current world or current market, okay, data is very important as compared to some all other things. Data is very important. Okay, in some cases software organization can give his can give its application logic or code, okay, freely to other customer, freely to other competitors. It is possible, but they will not do, they will not share at all their data, because it is very important. काही केसेसमध्ये ॲप्लिकेशन लॉजिक डायरेक्टली अवेलेबल करून देता येईल, काही केसेसमध्ये फ्रीली पण अवेलेबल करून दिला जातो, परंतु डेटा कधी अवेलेबल करून दिला जात नाही. डेटा हा खूप महत्त्वाचा असतो. सो डेटा इज व्हेरी इम्पॉर्टंट, राईट. सो बट इफ यू आर युझिंग टू tier architecture, then application logic as well as data is directly available to the attacker, and it is a very crucial thing, okay, as far as security is considered. So in case of two tier architecture, security is breached, okay, security cannot be maintained, okay, at a good level. So this is the first drawback of two tier architecture. Second drawback is it is difficult to maintain. It is easy to implement, but it is difficult to maintain. So maintenance is very difficult. Then next part is that these applications are not scalable. Scalable means, okay, you have created particular application to handle a load of 1000 clients, 1000 customers, and in future, okay, after 2 years you want to handle 1 lakh customers. In that case, okay, you have designed your server tier, okay, by using for example, by using some 10 machines, because you want to handle just 1000 customers, right? So you have designed that server tier with the help of 10 high speed machines, okay, but in future, okay, after 2 years, okay, you want to utilize such application, this particular application, to handle 1 lakh customers. So in that case it is very difficult, okay, because 10 machines cannot handle this high amount of load. So you want to scale these applications, but if you want to scale this application, you want to increase the size of this particular server tier. In that case you have to increase the size, but at the same time every machine contains application logic as well as database, application logic as well as database. So it is very difficult to scale these applications. Okay, so solution is that what we can do is, okay, we can divide this particular server tier in two parts. The first part is the application logic part, and the second part is the database part. So it means that, okay, you have created particular server tier with the help of 10 machines. Okay, then you first identify it for application logic part, how many machines are required. For example, for application logic you require 4 machines or 5 machines, okay, and for database how many machines are required, or how many server machines are required. Then if you required 5 server machines for database part, in that case you can separate out it, which machines are some of the machines, for let us suppose 4 to 5 machines are created or are handling the application logic part, and remaining 5 machines, server machines, are handling for the database part. So in that case you can separate out their roles. So if particular machine fails, at a particular crucial time, in that case it is very easy to replace that machine. Okay, you want to replace that only defaulty machines with some good machine, but working condition machine. So it is very easy to maintain this particular thing. And okay, so this is the advantage of performing this task, as well as it is very easy to scale this. Okay, so you know that, okay, you want to store information of 10,000 customers instead of 1,000 customer. You want to store information of 10,000 customers, so you want to handle a load of 10,000 customer. In that case, there is a no need to change the application logic. Application logic is same. Okay, the application logic created for 1,000 customers, it is also fine for the next 10,000 customers, okay, or the remaining customers. Okay, so in that case, there is no need to change the application logic. It means that there is a no need to increase the server machines working for application logic. What we can do is, okay, we can increase the machines for a data storage, for the database. Okay, initially you are using a 5 machines, now can use 25 machines instead of 5 machines. So you can easily scale up this application, because in this case it is clear cut idea that there is a no need to increase the size of the application code. We just want to increase the size of the database part. Okay, so we want to just increase the size of number of machines working on a database part. Okay, or for the data storage application, right? So if you implement in this manner, in that case we are having a 3 tiers. The first one is the presentation tier, the next or second tier is the application logic tier. Okay, because we have separated the machines which are working on the application logic, and the last tier is a database tier. Okay, in enterprise applications, generally database tier consists of higher number of machines, because it contains a higher amount of data. Okay, compared to the database tier, okay, they are having a less number of machines for a application logic part. Okay, and for a presentation tier we can have a huge amount of machines, and they are of a vast range. Okay, so they are very versatile in nature. Okay, it depends upon the customers. Okay, which customer is interacting with your application, okay, accordingly, okay, that type of machine will be changed. Okay, in ideal case, in real world, okay, we are having a customer, okay, which having the internet connectivity and using some smart device. Then in that case, that customer can connect with your application, or uh, with your services, right? So now from a 2-tier architecture we go to a 3-tier architecture, that is a presentation tier, then application logic tier, and the last one is a database tier, right? Now in this case there is only drawback. Okay, and the drawback is that, okay, where if you increase the number of tiers, okay, if you increase the number of tiers, in that case the total response time may be increase. It is not the case that each and every time it will increase, but in some cases it is found that, okay, the response time of the application, okay, may be increased. What is response time? The response time is nothing but, okay, client is giving a request at a particular instant of time, and client is getting a response after some time, right? Okay, so time lap between response and request, the time lap, okay, or duration of a time, okay, in which client has given a request and client is getting a response. For example, okay, client is giving a request as 9:58 p.m, okay, at night, and client is getting a response, okay, at 9:58.50, okay, so after 50 seconds. Okay, so response time is 50 seconds. So it is found that, okay, if you are increasing the number of tiers, in that case response time will increase. Okay, it is not the case that each and every time it will increase. In some cases it will decrease. Okay, but generally, okay, if you increase the number of tribes indefinitely, then it creates the problem with the response time. Okay, if you increase the number of tiers, and it may hamper your response time. ओके, हे खूप सोपं आहे. ओके, सो मी रिलेची शर्यत बघितली असेल. रिलेमध्ये जनरली काय असतं, 4 खेळाडू काय असतात, एका टीममध्ये असतात. ओके, आणि समजा 400 मीटर अंतरासाठी रिले असेल. रिले हे धावण्याचाच एक प्रकार आहे, तुम्हाला सगळ्यांना माहिती असेल. तर जनरली काय असतं, पहिला खेळाडू, टीममधला पहिला खेळाडू सुरुवातीचे 100 मीटर धावतो. 100 मीटरवर गेल्यानंतर दुसरा व्यक्ती त्याच्या हातातले जे काय स्टिक असेल किंवा जे काय वस्तू असेल ती घेतो आणि पुढचं 100 मीटर अंतर तो दुसरा खेळाडू धावतो. सिमिलरली त्याच्या हातातली वस्तू तिसरी व्यक्ती घेते, तिसरा खेळाडू घेतो आणि पुढचं 100 मीटर धावतो आणि त्याच्या पुढे जो राहिलेला असेल तो खेळाडू, चौथा खेळाडू परत शेवटची स्टिक हातात घेतो त्याच्याकडून तिसऱ्या खेळाडूकडून आणि पुढचं 100 मीटर अंतर कापतो. ओके, ह्या केसमध्ये असं काय नाही आहे की एक खेळाडू 400 मीटर धावू शकत नाही का, धावू शकतो. पण ह्या रिलेच्या प्रकारामध्ये काय जज करायचं असतं की कोऑर्डिनेशन. पहिल्या खेळाडू आणि दुसऱ्या खेळाडूमध्ये किती चांगलं कोऑर्डिनेशन आहे. कोऑर्डिनेशन चांगलं असेल तर योग्य वेळेला दुसऱ्या खेळाडूच्या हातामध्ये ती स्टिक जाईल किंवा जे काय असेल ते, काठी असेल, काही असेल, ती वस्तू जाईल आणि दुसरा खेळाडू धावू शकेल. कोऑर्डिनेशन म्हणजे थोडा जरी मिसमॅच झाला किंवा ह्या रिलेच्या खेळामध्ये जर एखादी व्यक्ती जरी लॅग झाली, समजा दुसरी खेळाडू लॅग झाली म्हणजे तिला जो धावण्यासाठी लागणारा वेळ आहे तो वाढला. समजा प्रत्येक ह्युमन बिईंग आहे, प्रत्येकाला लागणारा वेळ कमी जास्त असणारी. दुसरा खेळाडू जरा कमी असेल धावण्यामध्ये, त्याचा जर टाईम त्याने जास्त घेतला असेल तर शर्यतीचा रिझल्ट काय असू शकतो, आपल्या विरोधात जाऊ शकतो. म्हणजे ह्याच्यामध्ये खूप काय महत्त्वाचं आहे, कोऑर्डिनेशन महत्त्वाचं आहे आणि प्रत्येक खेळाडूने कमीत कमी वेळामध्ये तेवढं दिलेलं अंतर कापण्याचा प्रयत्न केला पाहिजे, तो झाला पाहिजे, तरच ती शर्यत आपल्याला जिंकता येते. Okay, similarly here also it occurs. Okay, so you are giving a request at presentation tier. At a presentation tier, particular machine is by using a particular device you are giving a request. Now this request is given to the application logic tier. Okay, application logic tier is having a set of machines. Particular machine is getting a request from the client. Okay, that particular machine is processing the request. Again, that machine is communicating with the machine which is present at a database tier. Okay, some storage activity is performed, then response is given to the application logic machine. Okay, or the machine which is present at application logic, and from a application logic machine, okay, response is given back to the client. So this particular part takes some time. So there are four branches here. Okay, first branch is from presentation tier to application logic, from application logic tier to database. Second branch, from database again back to the application logic. Third branch, and from application logic, third part, or from application logic to client, that is a presentation, that is a fourth part or fourth branch. Okay, so this is just a relay. Okay, if particular branch or particular part of this particular path is lagging, or it does not have that good coordination, in that case response time increases. So if you increase number of tiers indefinitely, in that case, okay, it hampers the response time. So this is the crucial thing. Okay, there is a concept called as the n tier architecture. Okay, extension of 3-tier architecture, it is also called as the n-tier architecture or multi-tier architecture. In some organization, it is also observed that, okay, they are maintaining a 4-tier architecture. And 4-tier for what? Okay, first is the presentation, second is the application logic, third one is the database tier 1 and database tier 2. So crucial data is stored, okay, in a database tier 2, and frequently used data is stored in the database tier 1. So it depends upon the enterprise or organization. Okay, the ideology of organization, complexity of application, okay, and there are number of parameters on which this particular design changes. So extension of 3-tier architecture is also called as n-tier architecture. So it is also called as a multi-tier architecture. If you replace the value of n by 3, then it is a 3-tier. Replace the value of n by 2, then it's a 2-tier, right? So 2-tier, 3-tier, 4-tier, 5-tier, and so on. So important thing is that you cannot indefinitely increase the number of tiers. Okay, theoretically it is very easy to call. If you are using an n-tier architecture, in that case you you are giving the response, okay, and you are maintaining the software very correctly or in a better manner. But practically